Hello world, today we're going to be going over a pretty interesting interview question. So the question is basically this. Write a function that will tell you whether two strings are permutations of each other. So a string is a permutation of another string if you can get from one to the other just by changing the order of the characters within it. So you can't replace any of the characters, you can't add more characters, remove any, all you can do is just change the order of them. And if you can get from one string to another by doing that, then they are considered permutations of each other. So in this example up here, we have uh, hello, and then we have LHEOL. So you can, if you jumble up the letters in hello, you could feasibly end up with this string. So that makes them permutations. So you would expect this to return true. Um, and that happens to work for the boilerplate we have, but it will always return true. So let's change this up. Let's figure out how we can change this function to make it so that it will return true only when the two strings are permutations of each other. So I'm about to start to dive into the solution. So if you haven't thought about this problem very much, I recommend giving it a try yourself. Um, I will tell you, you can do it in um, n time and n space, where n is the length of the longest string. Um, so with that in mind, let's get into the solution. So let's think about what it means for two strings to be permutations of each other. Because just asking if two strings are permutations, like um, that's not that useful of a question to ask, but if you can kind of make it a little more specific, the question becomes much easier to answer. So a string is a permutation when you can get from one string to the other just by rearranging the characters. So what that means is really two strings are permutations of each other if and only if for every character that appears, they have the same number of appearances in string 1 and in string 2. So let's think about that. The only thing that needs to be true for a string to be a permutation is they have the same number of each character. So we want a way to go through the strings and basically keep track of how many of each character there are. So the simplest way to do that would be to use a map of some sort. So in right now I'm coding this in Java, so I'm going to be using a HashMap. Depending on the language you're using, there might be some other sort of map data structure, or some sort of unordered map, or anything like that. But the general idea is that we want to have a mapping from characters to integers, and we are going to create that mapping. It's going to start off empty, and then we are going to go through both of the we're going to be going through both of the strings and sort of just counting the characters. So let's start by going through the first string, and for each index in the string, so for an I equals 0, I does not equal s1.length plus plus I. So for each index, let's take the character in that index. S1.char at I. So we're going to take each character, and we basically just want to check to see if it's in the mapping already. We want to increment it by 1, and if it's not in the mapping yet, then we want to set it to 1 in the mapping. And that's going to let us basically just keep track of how many times we have seen each character. So in code, that would be, we check to see if mapping.containsKey C. So that's if the mapping already has this. That means we've already seen this variable. We want to set the value of it to whatever it currently is plus 1. So that looks like this. And it is kind of ugly, but it gets the job done. Mapping. Cool. So this works. This handles this case where you just want to increment it. The other argument, the other case we could make is where the mapping hasn't seen this yet. Like we're iterating the first time we see a character, it wouldn't be in the mapping yet. So we just want to stick in, you just want to put in a value of 1. You could put this all on one line if you wanted to. You can do a little ternary operator there, but I think this way is a little bit easier to read. So this is actually it for going through the first string. Now we have all the information we need. We have a mapping that has all of the characters and how many times they appear. So now there are a couple ways you could proceed. The first way would be that we could actually go through string 2 and create a mapping just the same way we did with string 1, and then we could compare them and make sure that the same character comes up in each of them. And that would be a perfectly good solution. We can actually get away without creating that second hash map, though. That would save us a little bit of space. So let's try that. So at this point, we have a mapping. Let's print this out actually, just so we can see what our mapping looks like now. Just give us a bit of an idea of what we are working with. So we run this. So our mapping has 1 E, 1 H, 2 L's, and 1 O, which is good. Those are the letters in the word hello. So what we really want to check right now, going through our second, through S2, is that we have the same exact number of each of these. And what that means is we want to go through L2, or S2, and if we, instead of making a separate map and counting again, we could just count down on this map that we already created. And since we expect there to be the same number of each character, what we should expect is that we end up at exactly 0 of every character. So let's go through that. So we can, I'll do it above the print, so we can use the print to debug a little bit. So we are going to make a very similar looking loop as this time we're working with s2.length. And let's start with the same thing. Let's store the current character in a variable because we are going to be using it quite a bit. So we're going to go through, and for each character, we are going to check to see, again, this is going to look pretty similar, if mapping.containsKey, C. So right here, this has a little bit of a different meaning than we did in the first loop. With S1, we were checking to see if it was already in the mapping, because if it wasn't, we had to stick it in with a value of 1. Here we're checking to see if it's already in the mapping, and we know that if it's a palindrome, it has to be in the mapping already. Because if it's not in the mapping already, that means that this is a character that wasn't in the first string. And that means we immediately know that it's not in a palindrome. So we can actually just say right off the bat, if we find a letter in S2 that isn't in the mapping, that means it wasn't in S1, or sorry, not palindrome, permutation. Different problem. So this means that it wasn't a permutation if we find a character that wasn't in S1. So we can just right here return false. So that's pretty simple. So what happens if it is in the mapping? Well, then our problem becomes a little different. Then we just want to go through and we want to subtract 1 from whatever its current value is. So we can sort of copy this almost and just say, instead of +1, -1. We're just decrementing it now. And now this kind of leaves us with an interesting problem, right? So what we can do here is we can actually check right now if mapping.get C, so this is the number of times that C has shown up so far, is actually 0, that means that we are done with this character. right? That means that we are done. We don't have to look at it anymore. If it comes up again, then that means it's shown up too many times, and that's an issue. So we can actually just go ahead and remove C in this case. And this removes it from the map completely. So if we find it again, then we end up actually just on this step right here, this will be false and will return false, which is what we want, because that means that the character is shown up too many times. So this handles a lot of cases. So what happens then, the only case we really have left to worry about is the case where, right here we return true if we get all the way to the end. So the only way we can get all the way to the end right now is either, I mean, if we have a palindrome, this will never happen. And the other case is, what if we have a character that shows up less times in S2 than in S1? Then given our current implementation, that would cause an issue because we would never come into this return false because we only come into here if a character shows up more times in S2. So the fix for this is actually really simple. You could have it return mapping.isEmpty. That would work. A simpler solution, which is actually also just a good optimization in general, is before we even start to check, we can say if s1.length does not equal s2.length, we can return false right away. And this is because if two strings are different lengths, there's no way you can rearrange the characters in one to get to the other. You'd have to either add or remove a character. And that breaks the rules of having a permutation. So we know immediately if they aren't the same length, it's false. Which kind of actually ends up solving this problem. Because if you think about it, if two strings are the same length, and there's a character that shows up more often in S1 than S2, that means, since the strings are the same length, that there needs to be another character that shows up more often in S2 than in S1. And that would trigger this case right here, would have to come up at some point. So just by doing this check up here, this actually guarantees that we end up with the answer. So if we can get all the way through S2 without ever getting to this return false, that means that we have a permutation. So this should always just print, mapping should always be empty at this case right here. So let's go ahead and try to run this and see what we get. Perfect. So we get a true, and we can see we have this print here. Mapping is empty. So if we stick this in here, just to make it a little easier to see what's going on. Here we go. So we can see what mapping looks like at each step. So as we go through S2, which is LHEOL, on the first step we go from this, which has one of each character with two L's, to just one L because we process that first L. Then after that we process the H, so the H disappears going from here. There's no H down here. Then after that we go to the E, and then the E disappears on the next step, and then the O disappears, and finally that L disappears. So you can play around with this. We can change this so it's not a palindrome, permutation. So if we replace that O with another L, we do get a false coming back, because you do end up, once you process that third L, you do indeed end up with us trying to remove something that isn't in the mapping, because L's already gone here. So then by the time we try to remove a third L, we end up going into this case, which is why we return false. And yeah, you can play around with this. You can give it anything you want. Obviously, if you give it something that's a different length, it'll return false immediately. You do the check up here to see if their lengths are different. But yeah, that's really all there is to it. There are plenty of ways to code this. This is a pretty efficient way. If you're okay using a little bit of extra space, a simpler way might be to just get the mapping of characters for both of them, two separate maps, and just compare them character by character. But yeah, I mean, really the key to this problem is just knowing to use a mapping from characters to integers to keep track of the number of characters. Other than that, there are plenty of ways to solve it. Uh, this is one of the more efficient ways. But yeah, I'll make sure to post this in the description. If you have any questions, feel free to post them in the comments. Until then, good luck.